All right, let's talk about what a titration is. Basically, a titration is just a technique to determine the concentration of an acid. So right now, what it is just that I have a solution and I know that it's an acid, but I don't know the concentration. I'm going to use titration to figure that out. How do we do that? So let's keep going. In titration, we're using the theory of neutralization. That means that whenever a base and an acid are mixed together, they will neutralize each other to get water and a salt. And the neutralization between a base and acid will depend on the moles of each that's used. Remember, if you've done some neutralization reaction, we have to use stoichiometry to look at the molar ratio and make them equal. If you think about neutralization in the sense of like a seesaw, right? When it's neutralized, you have the same amount of acid and same amount of base. If something is very acidic, that means that you have lots of the hydronium ion. So that if this is very acidic, you have a lot of this hydronium ion and not so much of a hydroxide ion. And to neutralize it, you're going to add more hydroxide ion to balance this out. That's what a neutralization reaction is. Let's look at the setup of titration. Here's a diagram that I have drawn out with chemics.org. And if you look at this, I have a stand, I have a clamp, and I have a burette, just like what I have here. And then at the bottom of here, I have an Erlenmeyer flask with my acid. So that's my known concentration. I also have a strong base, and this is my sodium hydroxide. And this sodium hydroxide, I actually know the concentration, and I will know the volume that's available. And that's a really important part, is that when you make your strong base solution, you need to know what concentration you're starting off with, and with the known concentration, you will also figure out what the volume that you're going to use to neutralize it. For your acid, however, you don't know what the concentration is, so you don't know what the concentration is. However, you will know the volume because you know how much volume of acid you put into your Erlenmeyer flask, right? That is also an important aspect. So then how does titration work? So what's going to happen is that I'm going to pour this sodium hydroxide base into my burette, and at the burette, it's actually starting, the increments actually start at 0 milliliters and goes down to 50 milliliters, so then you know how much you put in. And at the bottom, this is where you would dispense the amount of base into your acid. So when you're ready to go, you fill your base, your burette with your base, and then you're going to dispense it by opening this, and it's going to dispense it, and then what's going to happen is you put a base into an acid and you neutralize it. That's all it is, right? But the question here is that, well, how do you know when the neutralization has occurred or when the reaction stops? With that, you have a complete neutralization. Well, this is where you need a pH indicator. And one popular one is a phenolphthalein indicator. It's going to change from a colorless to a pink solution when it's going from acid to a base. So you're going to put a couple drops of indicator into your acid, just like what I have here. So here's my Erlenmeyer flask. Here's my phenolphthalein. I put a couple drops in here. What's going to happen is that as I'm dispensing this base into my solution, my acidic solution, this acid is going to start turning basic, right? Because or start neutralizing. You're putting more base into an acidic solution. So then why are we using phenolphthalein and how come this works? So let's look at what exactly is happening. Let's look at this really basic standard neutralization reaction with sodium hydroxide and hydrochloric acid. When we have this is going to give you water and sodium chloride. That's your standard neutralization reaction. Again, this is where I start off with in this beaker, I have my sodium hydroxide. I know my concentration, and I'm going to know my volume too, because I'm putting this into my burette. For my HCl acid, I don't know my concentration, but I do know my volume, because I have 200 mLs of HCl in this Erlenmeyer flask. So then, if you were to remember how to do the neutralization reaction, if I were to tell you that, well, okay, so it takes you 50 mLs of this concentration to neutralize HCl, calculate what my concentration is, right? You know how to do that. That's your neutralization reaction. So this is really what titration is about, except that we don't know this 50 mLs of sodium hydroxide yet. We have to determine that. So how we determine that is that as we dispense the base into your acid, this acid solution is going to start changing colors. So it's going to start change colors to pink. And the reason why it changes colors is that we have put this pH indicator phenolphthalein in. And if you look at phenolphthalein, when phenolphthalein changes colors, that's when it has a pH range of 8.2 to 10. So as you're adding more base in, your pH is going to rise because you're putting a strong base in there. And as you add it in, it's going to change the colors. And that's when you're going to realize that, okay, that's when my neutralization reaction stops, because you have reached the neutralization equivalence point. That means that you have reached the point where you have the same amount of base and same amount of acid. And the phenolphthalein is a very effective indicator because it shows you when it is. So if you look at this graph, this is where you start off, right? This is your unknown acid. And as you add more base into it, this is going to rise. The pH is going to rise. And if you see from this point to this range, this is where it's reaching the equivalence point where you have the same amount of acid and base. And conveniently, phenolphthalein actually has a color change when it has reached the equivalence point. So when your solution changes colors, that's when you have the same amount of hydronium ion and hydroxide ion, or when your acid and base have neutralized each other. So when you're doing your titration, you're doing this very slowly. You're going to mix this in. Let me see if I can do this. Here is my base. I'm just going to pour this into my burette. Make sure you use a funnel, and then pour. So when I fill this burette up, right now the burette, I'm going to, if you can see closer, I'm going to let this, and as I'm draining and dispensing my acid here, I want to swirl because I want to make sure that I hit the equivalence point right on. I don't want to put too much base, and that's what we call overshooting. Okay, so let me show you how this works. So I'm going to continue dispensing. As you can see, there's no color change yet because I still have a lot of acid in here, but I'm going to keep swirling. One tip is that on your first titration, it actually might be a good idea for you to dispense a lot of your base in here, just to know and just to see when the color changes, because you want to have this pretty accurately. Okay, let me continue doing this, and it's still going. It's very slow. These burettes are very slow at dispensing because you want it to be drop by drop in accuracy. So I'm going to keep swirling this, and hopefully it'll change colors soon. All right. Okay, so as I dispense more, you can see that it's slowly showing some hints of pink in here, and I'm just going to keep going until I reach that equivalence point. So right now I still have not reached that point, and I'm just going to keep going. And to save time, I'm going to show you the effects of this. I'm just going to pour a big chunk of my strong base here. So you can see that it is turning pink, and this is what you don't want to do, is that you don't want to overshoot. That means you don't want to pour too much base into here. That means that you don't want to have yours change to pink really fast. So right now it still turns back to colorless, so it's okay. So this is where I want to continue dispensing very slowly. And you can see that it does turn pink a little bit, and for titration it does take a lot of time. And for time's sake, I'm just going to show you what I mean by the equivalence point here. Of course, you don't want to be doing this with another beaker. And as well, oh, you can see right now, this is really pink because I poured from the beaker. This is what they call overshooting, because right now the intensity of this color is really strong. That means I have overshot. That means I actually went over the pH range, and this is more, I have went over the neutralization point. You don't want to do that. You want to do it so that you want to end it when you get that first color change and it doesn't revert back to the colorless. That's when you stop. You don't want to be doing this, because just for time's sake, I just wanted to show you what that means for overshooting. But when you want to stop, you want to have the solution change colors and not go back to colorless. That's when you stop. Okay, that's your titration. And once you have done this, okay, so then where's the calculation part? So then once you have done this, you're going to look at your burette, you're going to read this number, and then you're going to calculate how much of this space did you use to make the color change. Once you have recorded that number, then I'm going to know that you have my concentration of sodium hydroxide, you know the volume of your the base that you use, and then you know the volume of your hydrochloric acid, and then you just do another neutralization reaction, and that's it for titration. So hopefully that has made sense, because I know it's a longer video and it is a somewhat of a tedious process. Titration just takes practice. Make sure you understand how to set it up and how to look at these numbers, because when you're given questions with the data table, you have to understand, like, that's the volume that you're using, and it just takes some practice to getting used to it. So hopefully that video has helped you. Thanks for watching.